Hey guys, I'm here to go over intro notes for Unit 9, Section 4, Factoring and Quadratic Equations. And 9.4 is all about perfect square trinomials. And today we're factoring special case quadratic equations. We learned some rules for multiplying binomials. So this is why we learned those rules. So what this is, factoring is basically the opposite of multiplying. You are undoing multiplication. So we're going to use something called the X-box method. You have an X and box that we have used to multiply. So our perfect square trinomial, I have a squared plus 6a plus 9. So what I'm going to do here is first I multiply my first and last term. So the coefficient on a squared is 1. So 1 times 9 is 9. And I take this middle term and put it on the bottom of my x. After I've done that, I'm going to list out all of the factors of 9. Have 1 and 9 and 3 and 3. So what I'm trying to find here is there's two factors that can add up to my middle term. So 1 plus 9 is 10 and 3 plus 3 is 6. So we're going to do 3a over here on the left and 3a on the right. Notice for my left and right spots on my x, I have included the variable. So what you're going to do now is you're going to take, I'm going to try to color code. You're going to take this term, put it in this box. So I have a squared. Think about how when we multiply, that's where that term goes anyway. And then my last term, it's too close of a color. Last term goes in this box. And then you take the two factors that you found right here and here, and they're going to go in that part of my box. So I've got 3a here and 3a here. So once I have my box filled out, I'm going to start finding the greatest common factor. That's why at the beginning of this unit we had a little bit of a review how to find the GCF. So here I'm now going to find the GCF of different combinations. So the GCF of a squared and 3a, remember in order for you to pull it out, it has to appear in both of my terms, and the only thing that appears in both terms is just 1a. I can't pull out a squared because 3a only has 1a to pull out. And then I find the GCF of 3a and 9, which gives me just 3. There is not an a in the 9 term, so I leave it as just a constant. And then I find the GCF of these combinations. A squared and 3a, I can pull out an a, and then 3a and 9, I can pull out a 3. So now, this should look familiar as what you would normally get using the box method. So that is my perfect square trinomial factored. Ends up being a plus 3, that entire quantity squared. So remember, if we're using the box method down here, I would set up my box like so. That's a terrible box. So now I have a plus 3, a plus 3, a squared, 3a, 3a, and 9, which gives me a squared plus 6a plus 9. This is why we taught you all those special cases for polynomials, to make this kind of stuff easier. So you can recognize that because this is a perfect square, I can, in my brain, recall that it is going to look like this when it is factored. Now here, what we just learned about was the square of a sum because they are being added, so it has a plus sign on your middle term. Now you have a negative sign on your middle term. You still start out the same way by multiplying 25 and 16. 25 times 16 gives me 400. Then I put my middle term on the bottom of the x. So now I got to list out the factors of 400. If you think about it, you're finding a perfect square trinomial. So your term here has to be multiplied to give me 400. So the square root of 400 ends up being 20. So 20 times 20 gives me 400. And if I add it together, it will give me 40. Notice it is a negative 40. So these become negative 20n and negative 20n. So now I'm going to once again fill out my box. So my first term is 25n squared. Last term is 16. And then I put the two terms that I found by factoring in these parts of my box. So now I want to find the GCF of 25n and negative 20n. There's not a negative in both of my terms, so I can't pull out a negative. We will deal with that negative later. So now I can pull out a 5n. At negative 20 and 16, I can pull out a 4. I can't pull out an n because it doesn't appear in both of my terms. Here, I can pull out a 5n. I can pull out a 4 right here. So this, factored as a perfect square trinomial, is now going to be 5n minus 4. That is where we take care of that negative. This is a square of a difference, so that's why you have a subtraction sign instead of a addition sign in between my terms. So if I use the box method down here to multiply my binomial, we should get the same answer. So now I've got 5n, oops, that little trick is still on, 5n minus 4, 5n minus 4, 5 times 5 is 25n squared, negative 4 times 5n is negative 20n twice, and then the negative times a negative is a positive, and I get 25n squared minus 40n plus 16, which you will notice is what we started off with right here. That is a square of a difference. And I can also rewrite this as 5n minus 4 squared. And that's where we get this a minus b quantity squared. Alright, so now instead of having 1 as the coefficient, we have 4 as the leading coefficient. So we still start out the same way. 4 times 9 gives me 36, and I pull down my 12. Now I want to find the factors of 36 that add up to 12, which, since it's a perfect square trinomial, you should already be thinking of what that might be. 3 and 13, not quite. 36 divided by 4 gives me 9. Still doesn't add up to 12. And then I get, oops, I skipped one, which is the one that we needed. 36 divided by 4 is 9. 36 can't be divided by 5. It ends up being 6 times 6. When I add those together, they have to be positive because my middle term is positive. So now I've got to fill out my box, 4x squared, 9, and then 6x and 6x. I pull out my GCF. X appears in both, and so does a factor of 2. Here, I can only pull out a factor of 3. Here, I pull out the same 2x and the same factor of 3. And this perfect square trinomial factored ends up being 2x plus 3 squared. The interesting thing about these is you can multiply them out to make sure you have done it correctly. So that is very handy for checking your work. Right. So now, for this one, I have 16t to the 4th minus 8t squared u cubed plus u to the 6th. It looks kind of intimidating because it does have multiple coefficients, but it is not difficult. So the first thing that I do is multiply my first and last term coefficients. 16 times 1 is 16. And I bring down my -8. And then I want to find the factors of 16 that add up to 8, which ends up being 4 and 4. They have to be negative because my middle term is negative. Now let's think about our exponent rules. When I'm adding things together that have the same coefficients with the same, the same variables with the same powers, I just add together their coefficients. So here on this 4, I should have a t squared and a u cubed on both sides, since I'm just adding them together. So now I'm going to fill out my x box. I filled out my x, now I'm going to fill out the box. So 16t to the 4th and u to the 6th, and then -4t squared u cubed, -4t squared u cubed. Now the GCF is a little bit different here because you do have multiple variables. So here I can pull out a 4, and I can also pull out t squared. Notice the u is not in the first term, so I can't pull it out. So I move on here. There is no coefficient on there is a 1 on my u, so I can't pull out a 4, but I can pull out a u to the 3rd. There's no t in my second term, so I can't pull out a t. So now I get 4t squared, and then here I get u to the 3rd. This factored is 4t squared minus u cubed squared. Notice it is a subtraction sign because this is a difference of squares, or a square of a difference. So here is a quick little trick. If you can recognize that you have a perfect square trinomial, you can square your first term, or square root your first term, and square root your last term, and it gives you this. So the square root of 4, the square root of 9, ends up being 2x. Here is just 3. So this squared ends up being 2x plus 3 squared. And then over here with my difference of squares, or square of a difference, I'm going to square here, here, just like I did the other problem. Square root of 16 is 4. The square root of t to the 4th is t squared. And square root of u to the 6th ends up being u to the 3rd. Because u to the 3rd times u to the 3rd, I add up my exponents. 3 plus 3 equals 6. So this gives me 4t squared minus u cubed. On the back of your notes, I've already done it, so I'm going to flip quickly and flip back. But that is how you work with perfect square trinomials and factoring. I hope you guys are enjoying some of your time out of the classroom, but you are keeping up with your work. As always, if you have a question, you can email one of your math teachers.